In this video, we are going to discuss homogeneous linear equations. Linear equations whose right hand side is all zeros are known as homogeneous linear equations. For example, equations in three variables x1 minus 2x2 plus 3x3 equals 0, 2x1 plus 5x2 plus 6x3 equals 0 are called homogeneous linear equations because the right hand side of these two equations is all zeros. Similarly, linear equations 2x1 minus x2 plus 3x3 equals 0 and 3x1 plus 2x2 plus x3 equals 0, x1 minus 4x2 plus 5x3 equals 0 are also homogeneous linear equations because their right side is all zeros. Hello friends, you are watching YouTube channel Number Collage. This channel features easy to understand concept videos on mathematics. Consider homogeneous linear equations in two variables x plus 2y equals 0 and 2x minus y equals 0. Multiplying the second equation by 2, we get 4x minus 2y equals 0. Now adding equation 1 and equation 2, 2y minus 2y will be 0, 5x will be 0, x will be 0. Now using this value of x in the first equation, we get 2y equals 0, that means y equals 0. Therefore, x equals 0 and y equals 0 is the only solution of these two linear equations, and this is known as zero solution. Now consider another pair of linear equations in two variables 2x minus y equals 0 and 6x minus 3y equals 0. If we divide the second equation by 3, we get 2x minus y equals 0, the same equation as the first equation. Therefore, these two equations represent two coincidental lines, which means they have infinitely many solutions, and these solutions will be called non-zero solutions. A set of homogeneous linear equations can be written in the matrix form as Ax equals O, where O is a zero matrix, A is the coefficient matrix, and X is the matrix of the unknowns. Obviously, the solution of this equation will be a zero matrix or a null matrix. Therefore, the solution x equals 0 is called trivial solution or zero solution, and the solution x not equal to 0 is called non-trivial or non-zero solution. We will see how to decide nature of solution of linear homogeneous equations from the rank of the coefficient matrix and number of unknowns. In the matrix equation Ax equals O, number 1, if rank of coefficient matrix A equals n, the number of unknowns, the only possible solution is x equals 0, that is a trivial solution or zero solution. Number 2, if rank of coefficient matrix A is less than n, the number of unknowns, then the system has non-trivial or non-zero solutions. Solve x1 plus 2x2 plus 3x3 equals 0. 2x1 plus 3x2 plus x3 equals 0. 4x1 plus 5x2 plus 4x3 equals 0. x1 plus x2 minus 2x3 equals 0. These are homogeneous linear equations because the right hand side is all zeros. We write the matrix equation Ax equals B 1 2 3 2 3 1 4 5 4 1 1 minus 2 multiplied by x1 x2 x3 equals 0 0 0 0. We will convert this 2, this 4 and this 1 0 by row transformations r2 minus 2 r1, r3 minus 4 r1 and r4 minus r1. So we get 1 2 3, 2 minus 2 0, 4 minus 4 0, 1 minus 1 0, 3 minus 4 minus 1, 1 minus 6 minus 5, 5 minus 8 minus 3, 4 minus 12 minus 8, 1 minus 2 minus 1, minus 2 minus 3 minus 5. We will convert this minus 3, this minus 1 and this minus 5 equals 0 by the row transformations R3 minus 3 R2 and R4 minus R2, minus 3 plus 3, minus 3 plus 3 0, 15 minus 8 7, minus 1 plus 1 0, minus 5 plus 5 0. There are 3 non-zero rows in the coefficient matrix A. So rank of coefficient matrix A is 3, which is equal to the number of unknowns 3, which implies the system has trivial solutions. This can be verified by matrix multiplication. X1 plus 2x2 plus 3x3 equals 0, minus x2 minus 5x3 equals 0, 7x3 equals 0. So this implies x3 is 0 upon 7 0, x2 is 0 and x1 is also 0. So this proves that these equations have only trivial solutions or zero solutions. Solve by matrix method following homogeneous equations. X plus y plus 2z equals 0, x plus 2y plus 3z equals 0, x plus 3y plus 4z equals 0, 3x plus 4y plus 7z equals 0. Let's write these equations in the matrix form: 1 1 2, 1 2 3, 1 3 4, 3 4 7. Now let's convert this coefficient matrix into row echelon form. To make 1 1 and 3 zeros, we will perform row transformations R2 minus R1, R3 minus R1 and R4 minus 3 R1. So it will be 1 1 2, 1 minus 1 0, 2 minus 1 1, 3 minus 2 1, 1 minus 1 0, 3 minus 1 2, 4 minus 2 2, 3 minus 3 0, 4 minus 3 1, 7 minus 6 1. Now to convert these ones and these twos, zeros, we will perform row transformations R3 minus 2 R2, R4 minus R2. It will be 1 1 2, 0 1 1, 2 minus 2 0, 2 minus 2 0, 1 minus 1 0, 1 minus 1 0. Now the coefficient matrix A is in the row echelon form. So here rank of coefficient matrix is 2 because of these two non-zero rows, which is less than the number of unknowns 3, which implies the system of equations has non-trivial solutions. A number of independent solutions will be this 3 minus 2, that is 1. By matrix multiplication we will get x plus y plus 2z equals 0, y plus z equals 0. Here we will put this z equals minus t so that this y will be t. Now using the values of z and y in the first equation, we write x plus t minus 2t equals 0, x minus t equals 0 or x equals t. So the independent solutions that we get will be x equals t, y equals t and z equals minus t. So these are the independent solutions that we get of this system of equations. Solve x1 plus x2 minus x3 plus x4 equals 0, x1 minus x2 plus 2x3 minus x4 equals 0, 3x1 plus x2 plus x4 equals 0. First we write these equations in the matrix form: 1 1 minus 1 1, 1 minus 1, 2 minus 1, 3 1, 0 1 into x1 x2 x3 x4 equals 0 0 0. These are homogeneous linear equations because the right hand side is all zeros. We will convert the coefficient matrix into row echelon form by row transformations. We will convert this 1 and this 3 zeros by row transformations R2 minus R1 and R3 minus 3R1. So 1 1 minus 1 1, 1 minus 1 0, minus 1 minus 1 minus 2, 2 plus 1 3, minus 1 minus 1 minus 2, 3 minus 3 0, 1 minus 3 minus 2, 0 plus 1 1, 0 plus 3 3, 1 minus 3 minus 2. Since second row and third row are equal, we will perform R3 minus R2 to convert this minus 2, 3 and minus 2, 0. Minus 2 plus 2, 0. 3 minus 3, 0. Minus 2 plus 2, 0. Now the coefficient matrix is converted into row echelon form. Rank of the coefficient matrix A is 2 because there are 2 non-zero rows, which is less than number of unknowns 4, which implies the system has non-trivial solutions. The number of independent variables will be number of unknowns 4 minus rank of the coefficient matrix 2, that is 2. First we will write the equations by matrix multiplication here. So we get x1 plus x2 minus x3 plus x4 equals 0, minus 2x2 plus 3x3 minus 2x4 equals 0. For independent solutions, we assign parameters to two variables, t1 for x4 and t2 for x3. So therefore, this x2 will be 3 upon 2 t2 minus t1. Using values of x4, x3 and x2, in this equation, we write x1 equals this minus x2, that is t1 minus 3 upon 2 t2 plus x3 minus x4, that is minus t1. So t1 cancels with this t1. t2 minus 3 by 2 t2 will be minus half t2. Thus we get the independent solutions of this system of linear equations as x1 equals minus half t2, x2 equals 3 by 2 t2 minus t1, x3 equals t2 and x4 equals t1. We can verify that this solution is correct by substituting the values of x1, x2, x3 and x4 in these equations. We have to show that the system of equations 2x minus 2y plus z equals lambda x, 2x minus 3y plus 2z equals lambda y, and minus x plus 2y minus lambda z equals 0 can have a non-trivial solution only if lambda equals 1 and lambda equals minus 3. We have to obtain general solution in each case. We rewrite these equations as 2x minus lambda x, that is 2 minus lambda x minus 2y plus z equals 0, 2x minus 3 plus lambda y plus 2z equals 0, and minus x plus 2y minus lambda z equals 0. These are homogeneous linear equations. We first write their matrix equation, which will be 2 minus lambda minus 2 1, 2 minus 3 plus lambda 2 minus 1 2 minus lambda xyz 0 0 0. For non-trivial solutions, determinant A should be 0, so that will be this 2 minus lambda into lambda square plus 3 lambda minus 4 plus this minus 2 into minus 2 lambda plus 2 plus 1 into 4 minus 3 minus lambda equals 0. So that will be 2 minus lambda. Factors of lambda square plus 3 lambda minus 4 will be lambda plus 4 into lambda minus 1 minus 4 times lambda minus 1 minus lambda minus 1 equals 0. Taking lambda minus 1 common, we write lambda minus 1 into product of 2 minus lambda into lambda plus 4 will be 2 lambda plus 8 minus lambda square minus 4 lambda minus 4 minus 1 equals 0. That will be lambda minus 1 into minus lambda square minus 2 lambda plus 3 equals 0. Lambda minus 1 into factors of lambda square plus 2 lambda minus 3 will be minus of lambda minus 1 into lambda plus 3 equals 0. So that gives us lambda equals 1 and lambda equals minus 3. Therefore, the system has non-trivial solutions if lambda equals 1 and lambda equals minus 3. Now, in order to find the general solution, we will take lambda equals 1 and lambda equals minus 3 one by one. So, first we will take lambda equals 1. Let us rewrite the matrix equation in lambda. Now putting lambda equals 1, this equation becomes 1 minus 2 1, 2 minus 4 2, minus 1 2, minus 1. We will convert this coefficient matrix into row echelon form by reducing this 2 and this minus 1 to 0. For that, we will apply row transformations R2 minus 2R1 and R3 plus R1. 2 minus 2 0, minus 4 plus 4 0, 2 minus 2 0, minus 1 plus 1 0, 2 minus 2 0, minus 1 plus 1 0. There is one non-zero row in this row echelon form, therefore its rank is 1, which is less than number of unknowns 3. Therefore, there will be 3 minus 1, that is 2 independent solutions. By matrix multiplication, we get the equation as x minus 2y plus z equals 0. For two independent solutions, we assign parameter t1 to this z and parameter t2 to this y. That gives us the value of x equals 2t2 minus t1. So the solutions will be x equals 2t2 minus t1, y will be t2 and z will be t1. Next, let's find solutions of this equation when lambda equals minus 3. When lambda equals minus 3, this equation becomes 5 minus 2 1, 2 0 2, minus 1 2 3. In order to convert this coefficient matrix into row echelon form, we will reduce this 5 and this 2 to 0, and for that we will use row transformations R1 plus 5 R3 and R2 plus 2 R3. That gives 5 minus 5 0, 10 minus 2 8, 15 plus 1 16, 2 minus 2 0, 0 plus 4 4, 2 plus 6 8, minus 1 2 3. Now to convert this 8 and 16 0, we will use row transformation R1 minus 2 R2. That gives 8 minus 8 0, 16 minus 16 0. This is row echelon form of coefficient matrix. There are two non-zero rows in this matrix, so rank of this coefficient matrix is 2 less than number of unknowns 3, and there will be 3 minus 2, one independent solution. First we will write the product of these two matrices and write the equations. 4y plus 8z equals 0, minus x plus 2y plus 3z equals 0. We will assign one parameter to this z, which is t, so that this y becomes minus 8 upon 4, that is minus 2t, and using these values of z and y in this equation we get x equals minus 4t plus 3t, that is minus t. So the solution of the equation when lambda equals minus 3 is this x equals minus t, y equals this minus 2t, and z equals t. Friends, if you like this video, please click the like button. Share this video with your classmates. Don't forget to subscribe this channel to get more videos of this type. Give your comments to make these videos better. You can suggest topics on which you want me to make videos. See you in the next video. Until then, keep watching Number Collage. Thank you.